So far, we represented precipitation reactions by molecular equations. In such equations, species are written as complete formulas, even if they are strong electrolytes and exist as dissociated ions in solution. For a more accurate representation, strong electrolytes can be written as dissociated ions. That means all soluble ionic compounds and strong acids are written as separated ions. All others, which are insoluble ionic compounds, weak electrolytes, and non-electrolytes, are represented by their complete formulas. This gives us the complete ionic equation. In our example, potassium iodide is a soluble ionic compound. Therefore, it is a strong electrolyte. In water, it exists as dissociated ions, and it is represented by writing its ions separately. The coefficient must be considered. Thus, the correct number of ions is 2 potassium ions and 2 iodide ions. Lead 2 nitrate is also a strong electrolyte, and thus it is written as separated ions. The formula produces 1 lead 2 ion and 2 nitrate ions. Considering the products, potassium nitrate is written as separated ions because it is also a strong electrolyte. For potassium nitrate, 2 potassium ions and 2 nitrate ions are written. Lead 2 iodide is an insoluble solid. Therefore, it is written as a complete formula. In an ionic equation, there may be some species that do not participate in the reaction and remain the same. These are called spectator ions. In this example, potassium and nitrate ions are unchanged, and they are spectator ions. Spectator ions cancel out of the equation, and the remaining species are rewritten to obtain the net ionic equation. The net ionic equation is the ultimate reaction equation that shows the essential reaction. To write the molecular ionic and net ionic equations, start by writing the balanced molecular equation by predicting the products by trading ions between the reactants. For the reaction between potassium sulfate and silver nitrate, the products are potassium nitrate and silver sulfate. Potassium nitrate is soluble, silver sulfate is insoluble, therefore it is the precipitate. Then write the ionic equation by separating the strong electrolytes into their constituent ions. Potassium sulfate breaks down into potassium and sulfate ions. Silver nitrate breaks down to silver and nitrate ions. Potassium nitrate breaks down to potassium and nitrate ions, and the insoluble product silver sulfate is kept as an intact formula. In the complete ionic equation, there are 2 spectator ions. The potassium ions are left unchanged, as well as the nitrate ions. Therefore, they cancel out. The remaining species are the 2 silver ions, the sulfate ion, and the silver sulfate precipitate. The remaining equation is the net ionic equation. How about weak electrolytes? Since only strong electrolytes are written as separated ions in the ionic equation, weak electrolytes stay in molecular form. In the reaction between phosphoric acid and silver nitrate, the products are nitric acid and silver phosphate precipitate. When writing the ionic equation, phosphoric acid is kept in molecular form because it is a weak acid and a weak electrolyte. Silver nitrate is a strong electrolyte, therefore it is written as separated ions. Nitric acid is a strong acid, therefore a strong electrolyte and written as separated ions. Silver phosphate precipitate is kept in molecular form because it is the insoluble product. The spectator ion in this complete ionic equation is the nitrate ion. After cancelling the nitrate ions, the net ionic equation contains phosphoric acid, silver ions to produce hydrogen ions and silver phosphate precipitate.